Hi, students, and welcome to our lesson today. We'll start today with a do now question about diverse people, different kinds of people, which is what makes the world go round as far as I'm concerned. Our objective today will be to divide monomials, and then we'll answer our essential question, how should I handle those exponents when I divide monomials? So for our assignment, we will work on our do now. We will complete the work page and be careful with what we call coefficients. Complete the exit ticket. And remember to show me your work. So if you don't get finished, that's okay. You can finish it later this evening or after school. And I have some little things for you to do if you do finish early. I've got a link to the Tate Museum in London, their street art app, and then there's a little diversity puzzle that you can do. So you should be pretty busy this period. Here's our exit ticket, and we'll get back to that when we finish our lesson. So let's move on to our do now, like we always do, and we complete it in teams. What are some characteristics that culturally diverse people are likely to share? So, I'm a person of a certain age, and I came from Philadelphia, which is in the United States. It's a big city. I went to school, I went to college. Maybe you are 13 years old and come from a different place than I came from and a different time that I came from. So there's lots of things about us that are different. This asks, what are we likely to share? Well, I think there's a lot of things. I think we could share maybe a love for music. How about honesty? We love people and ourselves to be honest. How about kindness? Do we share that as a value? Okay. What else? Characteristics. Love of music, honesty, kindness. How about loving to learn? Love to learn. Well, I'm always talking about those grandchildren, and you have families that you love too. So, love of family. So, even though we might be very, very different, there's a lot of things that we share together. And I know one of the things I share with you guys is our time together at school. And you've been wonderful students this year. And it really has been a joy to teach you. And I love to hear what you have to say when you share. So the only thing, what I always said, we should put your cameras on more because I think it enriches me to see you so much, and I think it enriches you to see each other. So I hope you answer that. So we're dividing monomials, and when we divide, the answer we get is called the quotient. So we said when we add, we get a sum. When we subtract, we get a difference. When we multiply, we get a product, and when we divide, we get a quotient. So we have what we call the quotient rule. And when you divide monomials, we usually do it in this form with a fraction bar. We call that a vinculum. And although it doesn't have to be with a fraction bar, but usually this is how we show monomial division. But what we do when we divide these monomials, what do we do with these exponents? Well, what we do is we divide our like terms and then we subtract the exponents. So it would be a minus b. Now, sometimes that's easier to understand if we look at some examples. So here we have 12 to the 7th divided by 12 to the 5th. So that would be 12 to the 7 minus 5, which would be 12 to the 2nd power. In the next instance, we have negative 6 to the 12th power divided by negative 6 to the 4th power. So that will be negative 6 to the 12 minus 4, and that would be negative 6 to the 8th power. And if we used our calculator to actually calculate that, this first one would be 144. The second one would be 1,679,616. These numbers with exponents can get pretty big pretty quick. Number 3, we have 4 to the 10th power divided by 4. And this 4 has an invisible exponent of 1, So that would be 4 to the 9th power. Okay? And that would be 4 times 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 4, or 262,144. Lots. Okay, exponents make numbers get big, but this is what we're learning today. So number 4, 9 to the 3 minus 9 to the 5th, divided by 9 to the 5th will be 9, 3 minus 5. That means we're going to end up with a negative exponent of -2. And what do we do with that? The negative exponent, we make it positive and we put it under a numerator of 1. So we put it in a denominator. Now we have 8 to the 6 divided by 8 to the 6. So that would be 8 to the 6 minus 6, which equals 8 to the 0 power. And we say that anything that's raised to the 0 power equals 1. So 1 is our final answer there. And in number 6, we have -5 to the negative first power. So let's get this right. Let's write it out. -5 to the negative first power minus 2. And that's going to equal -5 to the -3 power. Well, we've got to get rid of that exponent. We do so by putting 5 to the 3rd as a denominator under 1, and that's our final answer. So this also works when the base, remember, this is the base, this is the exponent. Okay, let's look at the first example, base, exponent. So it also works when the base is a variable. So we have x to the 10th minus 2, which would be x to the 8th. So let's try 7, 8, 9, 10, 11, and 12 yourself, and let's see how you do with that. Okay, so number 8, w to the 2nd divided by w to the 7th, that would be 2 minus 7, which would be w to the -5th, and we would need to write that as a positive exponent by making it a denominator under 1 as a numerator. So with this number 9, we have p to the 1st power, okay? And p to the 1st power is divided by p to the 4th power. Remember, that's an invisible 1. So that would be p to the 1 minus 4, which would equal p to the -3rd power. We want to make a positive exponent, so we put it in the denominator under 1, p to the 3rd power. And number 10, do each of the variables separately. So m3 minus 2 would be m to the 1st power, and that's going to be an invisible 1, so we just leave the m like that. The n is 6 minus 2, which is 4, and that's our final answer. Number 11, we do the r's separate from the s's, so the r would be 2 minus 3, which would be -1, which would be, 2 minus a -3. So 2 minus -3, in which case we would add, when we subtract a negative, we add. So that would be r to the 5th. And the s would be -5 minus 2, which would be s to the -7th. And let's put that all together. The r can stay in the numerator, r to the 5th power. S goes in the denominator, and then we can give it a positive exponent of 7. And now number 12. So we have our a. 2 minus 9 is -7. Our b values, b, 9 minus 3 is 6, and our c, 4 minus 4 is 0. So the c is going to go away because c to the 0 power equals 1. So that will become an invisible 1. b is fine, b to the 6th power, but it's going to have to become a numerator for a to the 7th power because we need to put a in the denominator. And that is our final answer. We got rid of the c to the 0 power because when you multiply anything by 1, that's an identity. It just equals itself. So that can become an invisible 1. Now, we've got some division examples here. When we do the division, we divide the coefficient. What is the coefficient? The coefficient is the number in front of the variable. So if a number is by itself like that, it's not a coefficient. We call that a constant. But if the number is in front of a variable, then we call it a coefficient. So let's tackle number 13. We have 24 divided by 8, which is 3. So that's done. Then we have C, 10 minus 3, which is 7. So this is 3C to the 7th power. So try a couple of these. Try 14, 15, and 16, and let's see how you do with those on your own. Okay, you ready to get to work? Let's see how you did. We have negative 36 divided by a positive 4. Negative divided by a positive is a negative, so that would be negative 9. We have k to the 6th divided by k to the 4th, so that would be k, 6 minus 4, which is 2. Number 15, we have 10 divided by 2, which is 5. We have x, 3 minus 4, which is negative 1. So we're going to have to rewrite this. We can put 5 as a numerator under x to the 1st power as a denominator. And this little exponent of 1 can become an invisible 1 because we don't write the exponents of 1. If they're negative 1, we have to write them. But if they're positive 1, we do not write them. So now number 16, we have 20 divided by negative 5. So our answer will be negative. 20 divided by 5 is 4. And then we have a to the negative 12 minus, be careful here, negative 4. And when we subtract a negative, it makes it positive. So that would be negative 12 plus 4, which would be negative 8. So this is going to equal negative 8. So now negative 4 stays in the numerator. Negative numbers can be in the numerator, just not negative exponents. And a to the 8th goes in the denominator. Let's make my a a little bit bigger so that my 8 looks a little bit more like an exponent. There, that's a little bit better. And that's our final answer. So let's go on to our exit ticket and talk about that. So describe how to divide monomials with coefficients. So to divide monomials with coefficients, the first thing you do is divide the coefficient. Okay, that's the number in front of the variable. The second thing you do is simplify the variables using the quotient rule. And the quotient rule is if you have x or any number to the a power divided by x or any number to the b power, that equals x to the a minus b, which you will simplify. So good job with that. Proud of those of you who just stay with it day in and day out. You know that your education is something you do for you, and you're staying with it right through to the end of the year. You're making me so proud that I have this little game for you. If you click on that link, that will take you to the Tate Art Gallery in London, which has a really fun app that you can do some street art. You can be like a graffiti artist and make some fun art. Do that for a couple minutes. And we also have a very neat puzzle that I made for you that celebrates diversity. So if you finish up early, you have those really fun things to do for a little mini break before you go on to your next class. Thanks for working hard. Remember, keep practicing. Remember, show your work to the teacher. And the more you do, the better you'll get. And as always, you'll be great.